In atoms, after discussing about the Bohr's theory of an hydrogen atom, in that hydrogen atom now we are going to discuss about the energy levels. What are the energy levels? Means we know that the electron is revolving in a constant orbit unless if the external there is no any external energy is acting, means the sum of the energy absorbed by an hydrogen by changing its temperature. Then the electron is always revolving in a path around this path is considered as a stationary orbit. The energy does not radiated when the electron is in the same stationary orbit, which is possible its angular momentum which is equal to h by 2 pi. So here we are considering that nucleus, the electron is revolving around the orbit. In hydrogen atom there is a one electron is there, it is one proton, but when around the nucleus there is a number of orbits are there. When the electron means the energy by changing the temperature around the for a room temperature, electron energy always we know that it will be stays in the constant, it will stays in the same energy level. So different energy levels are there whenever electron is in the nearmost orbital to the nucleus, means electron is having that the first orbit, then that will be called as unexcited state. The state where the electron without any at the room temperature where the electron stays around the nucleus is revolving in the hydrogen atom, which is the electron is revolving nearmost orbital, that is at one orbital. This is having the energy levels are E1 is equal to energy at first orbit, that is 13.6 electron volts. That is a 13.6 electron volts. And if in case of the electron is in the second orbit, the second orbit has having the energy levels, these are that is a minus 3.4 electron volts, minus 3.4 electron volts. At the third energy state, this one is the first one, the second one, third one, whenever E3 is equal to the third orbital has having the energy levels of that is a minus 1.5, minus 1.5 electron volts. So if in case of E infinity is having that, we know that 0, because according to the E energy equation, that is m into e power 4 by 8 minus m into e power 4 by 8 n square epsilon n cube h cube epsilon naught square, then from that equation energy is inversely proportional to its n square. So that's why if in case of E infinity, that is 1 by infinity is equal to 0. So here we are going to discuss about that when a particle, we are taking the hydrogen atom, in that hydrogen atom at room temperature that will be stays in the electron revolves in a stationary orbit. By absorbing, it doesn't radiate any energy. The electron at room temperature, whenever it is revolving around the nucleus, it does not, it is in the stationary orbit, so it does not radiate any energy. But by giving some of the minimum energy to that one, means if the energy absorbed by an hydrogen atom, the electron will be having some of the energy and it will be excited, which is ready to jump from the one ground state of an orbital to the another outermost orbital. It will be stays, it will be excited by absorbing some energy, it is excited. So that excitation, that is called the process, means the minimum energy required to excite an electron from its ground state to one of the higher energy state, to jump from the means one state of orbital to the another energy state of orbital, means lowermost orbital, lowermost energy of orbital is considered as a unexcited state, also called as a ground state. When the electron is are in the ground state, by absorbing some of the energy, the minimum energy required to an electron to move from the lowermost orbital, that is ground state of an orbital, to the ground state of an orbital to the outermost of high energy orbital, the minimum energy is called as a excitation energy. So that in that case of the minimum acceleration potential, which is the electron which is ready to jump from the, it requires some potential to jump from the ground state of an orbital to the high energy state of an orbital, which is provided by an energy, some of the energy given to an electron, that is some of the minimum energy accelerating potential which provided by an electron energy sufficient to jump from the innermost orbit to one of the outermost orbital. Means whenever electron is in the ground state of an atom, then by absorbing some of the energy, the accelerating potential, the minimum accelerating potential required by an electron, which provides the electron energy to jump from the innermost orbital to the jump from the outermost orbital. Whenever the electron has to jump from the outermost orbital, that required potential is called as that accelerating potential is called as excitation potential. Excitation potential means the amount of energy required for an electron to move from the one ground state of orbital to the another highermost orbital, higher energy orbital, that will be the minimum amount of energy required is called as excitation energy, and the minimum accelerating potential required, which provided by an electron energy, is sufficient to jump from the innermost orbit to the outermost orbital, is called as that potential is called as excitation potential. So that we know that the whenever that is which is equal to the E1, and the difference between the two energy levels means whenever it is jumps from the innermost orbital to the outermost another orbital, whatever the excitation is, the second most orbital or third most orbital or infinity orbital. So by taking the values here, whenever in case of the hydrogen atom is jumps from the innermost orbital to the next orbital, means E1 to the E2, means whenever the difference between the whatever the energy levels, what are the energy levels means the amount of energy required, that is E is equal to E2 minus E1, then minus 3.4 is the second energy state, which is having the energy levels, that is minus 3.4, and ground state of an atom means ground state, whenever the hydrogen is in the ground state, that energy levels are will be the minus 13.6 electron volts. By calculating this one, we can need 10.2 electron volts, means 10.2 electron volts energy required by an electron to jump from the innermost orbital, means ground state of orbital to the ground state of an atom orbital to the high energy orbital, means secondary orbital, secondary high energy orbital. So that here the whenever the ground state of an atom is considered as when at room temperature the electron stays in the nearmost orbital. When the energy is absorbed by an atom, the electron which absorbs by an atom, some of the energy is absorbed by electron, then it jumps from the lowest orbital to the high energy orbital, means jumps from lowest energy levels to the highest energy levels. Means that high energy excited state is not a constant state, it will be decreased, means the energy is almost all immediately it will be decreases, and it will again it will comes to the ground state. This will be not the fixed state, it's a temporary state, it will not constant, so that's why it will immediately it will comes to the ground state of an atom. Means whenever electron is in the state, by absorbing if the atom is absorbed some of the energy, it will be the atom is excited, that is called as excited state. And if the body comes to same position, means by absorbing while the electron is jumps from the high energy orbital to the low energy orbital, it radiates some of the energy in photons, some of the photons is emitted. So that is equal to h nu, which is equal to h nu. So that's why we consider that in the Bohr's third atomic, Bohr's postulates the difference between the two energy levels, which is equal to number of photons, that is h nu. So here hydrogen atom, which is required that the excitation energy is the minimum energy required to excite an electron from its ground state to one of the higher energy states is called as excitation energy. And the minimum accelerating potential which provides by an electron energy is sufficient to jump from the innermost orbital to the another one of the highermost orbital is called as excitation potential. So this is about excitation potential. Then if we come for the ionization energy and potential, what is meant by the ionization energy? Means simply we can say that if the electron which are revolving in a valency orbital, that is revolving due to that the centrifugal force, whenever it is having the centrifugal force which is balanced by the electrostatic force of attraction, we know that the net electrostatic force of attraction is balanced by that centrifugal force. So that if we give some of the energy, that electron is always tries to escape from an valency orbital, so that's why the electron can jumps from the valence orbital by giving some of the energy. So that the minimum energy required to liberate or to remove an electron from its outermost orbital is called as a process is called as ionization. Means here the phenomena of removal of an electron from its outermost orbital is called as ionization, and also the minimum energy required to remove the electron from its valency orbital is called as ionization energy. Ionization energy means some of the energy which is required is always try to escape from the valency orbital, so that if we give more energy to this, then more than the net electrostatic force that electrons will excited, and due to that the excited state means by removal of an atom from the excited state. If in case of the energy which is required to remove or we can say that the energy required to excite an electron to escape from the valence orbital, that is called as ionization energy. So that here the energy required to removal of an electron from an atom from the outermost orbital is called as ionization potential. If we require that, if in case of if E infinity is equal to 0, we know that which is required from the ground whenever it is in ground state of an atom, that is 13.6 electron volts. So if we want to ionization energy will be E is equal to E infinity means E infinity minus E1, that is whenever we can get that 0 minus 13.6 electron volts, that is the same amount of which is whenever the electron is in the ground state, the same amount of energy which is required to liberate an electron from the valency orbital. This is about ionization energy, means the potential, the minimum accelerating potential which is provided by an electron energy to liberate an electron. To liberate the potential required by an electron is called as it is provided by an electron energy is called as ionization potential. So this is about energy levels in hydrogen atom we have taken.